Hello, welcome to this presentation. This presentation is about modeling of our sites. As you saw in our previous presentations for BIM, we concentrated so much on understanding the building, drafting the building. But for now, we want to understand our site, and the process will involve drafting the site and modeling the site. So welcome. Thank you. Our first step will be to identify our site. And for me, I want to use a site that is in Murang'a. It's called Don Bosco Primary School. Just for clarity, I'm doing this in honor of a friend, but I'll use the primary school to help us understand the process of modeling. So Don Bosco Primary School is a Catholic-run institution in Makuyu, Murang'a. And as you can see, it is it's quite developed. So what I want us to do will be to model the site of the larger Don Bosco institution and a bigger area from Don Bosco. Now, remember our rule of thumb is that the area that you want to model should occupy around 10% of your sheet, okay? So that we are able to pick up the site and also pick up the neighborhood, okay? So in our case, as you can see at that zoom, if I take it that way, it will be too big. If I take it there, for me, that is manageable. So I will take that view, okay? So two things. It's always good to screenshot whatever you are doing so that it can pick up some information quickly. I've changed the dimension there to meter so that you're able to even scale, okay? So ensure that you take a screenshot of that portion of work. And for some of us who are using Windows, it's simple, just click the Windows button, hold Shift and S, do that simultaneously, and it will save. For now, I want to save the full screen. Do it again. Taking the full screen. And the full screen, should be able to come out. I don't know why it's not coming out. Anyway, I'll sort it out. So once you have done that, you will need to take coordinates of where you want to model. In my case, this is the larger Don Bosco area. So let me just take the coordinates of the center. So you right click and then you take those coordinates. We will use those coordinates in the contour map creator to help us generate the contours. We have a tutorial dedicated for contours, so I will not spend considerable time there. But as you can see, the first thing is to identify the position. The second thing is to identify the extent of your modeling. Again, rule of thumb, your site should be around 10%. Mine will be slightly smaller than 10%. Then you get your data. Your data, you get it by looking for the most northwestern point. and the most southeastern point. Then you get data. Okay, it automatically gives contours, and you can see from the pattern, the blue, this is the lowest part, and the red, this is the, okay, so it's sloping that way downwards from the red area to the blue. And for some of us who are conversant with this site, you'll agree that that's a pattern. However, we are not interested in using the number of levels. For contours, you must know your contour interval, so we must use a contour interval. Let us place a contour interval of 1 and see the result. That's a contour interval of 1 meter, okay? And you can now clearly see there's a pattern, okay? And we can clearly pick what we'll call the highest areas of our site, okay? For me, I will advise you to, so that you have a detailed model, given a chance, I'll push it to even 0.5. What you'll notice that it will double our contours, okay? When it's doubled, the better, okay? So that you have a lot of clarity in terms of your site. Look at that area where you can call the tip or the top part of our site. Right now, it has quite some clarity. Suppose I used a 0.2, again, it will more than double, okay? And it even gives more clarity, okay? However, when the contour interval is low, the number of contours increase considerably, okay? So you need to have a balance. So for the sake of this tutorial, allow me to use 1 meter. If I had time, I would have used a 0.5. A 0.5 is a better compromise, okay? So with a 1 meter contour interval, you can see how our contours behave. Again, rule of thumb, the blue is the lowest part, the red is the highest part. So you can see that our site is moving from this point going up. We have a tip here. You can see this tip here also. We also have another tip here, but it's red. So it means that this tip in red is higher than this one. But what's happening is that we have 2 mounts, and then we have a small shallow area between the 2 mounts. As you can see, the mounts are not far away from one another. So what I can easily deduce is that at the primary school is the highest point, and then it's looping somewhere around this area. Unless something has been done, they normally experience a lot of water drainage challenges, because that is where you have something like the lowest point, something like a valley, and that green shows us that. Okay. Now, with that, we have the relevant information that we need. You must, this level allow me to use must with capital letters. You must always ensure that you capture that information by screen grabbing, okay? So I will do the screen grabbing again. This time, allow me to use this option. Help me understand. And while you're doing your screen grab, kindly ensure the following. That one, don't know why the screen grab is not showing. But always ensure the following, that one, the sampling or the coordinates are properly picked up. Your plot option is properly picked up so that we know what you are using. In our case, you're using the level interval at an interval of 1 meter, okay? You must always save that information. Failure to save that information, when you need it later, it might give you issues, okay? So I will save it later, but for now, allow me to proceed on. So once you have done that, you need to export this map with the contours to Google Earth. This should help you enhance 2 or 3 things and even help in auto scaling so that when you're exporting it to Archicad, you don't have any problem, okay? So how we do that? How do we do that? We do that by exporting or download the KML file. These are Google Earth type of file. So if I just click KML file, it will automatically open itself in Google Maps, in Google Earth. And you can see for me, since I'm a frequent user of Google Earth, it will list it amongst the temporary files. So let's look at the temporary files. So here it is, okay? And at this level, I can even rename it. I can call it Makuyu site. And I always like linking the contour interval at 1 meter so that anytime, because you'll be using various contour intervals, if you have to revisit what you are doing initially, you will not have any problem. So as you can see, we have our contours now embedded on a Google Earth, okay? It's not different from what we have. The only thing is that now they are not colored. That's why you need your color-coded screenshot to guide you on that, okay? But if we quickly observe our site, you see we have a main road, okay? That's going through the police station as it meanders away from Makuyu, okay? We have the facility that's so much consistent to what we saw on Google Earth and the contour map creator. Within the facility, we have various roads, okay? So I'll want us to put it in a view that we can easily see those things on plan. There it is. There are 2 or 3 things that you need to do on Google Earth before you export it on Archicad. The first thing is usually to define the extent of your site. You define the extent of the site. How do you do that? You do that by using various tools. There are some tools that are shown here. Allow me to just push it a little bit so that we're able to see, okay? We have various tools for placing place marks, for the polygons, the paths, the place marks. I will practically show how you get a pin on site and you translate it here. We are going to handle that in a later tutorial. The polygon is an important tool because it can help you quickly define an area. In this case, allow me to define the extent of our school, okay? The extent of our school can be easily defined. I can call it extent of primary school. I can easily pick it up. I just need to place the dots. As you can see, as I'm placing the dots, a polygon is being drawn. Normally, it's good when you use a colored fill when drafting it so that you can see the extent of what you are covering. And once you are done, you adjust it. You change the opacity to even around 20%, even 30%, and you change the color. Allow me to use green. The key thing is that we should be able to see it in terms of color, but the beauty is that the polygon will have defined the extent of our site. So for now, allow me just to define that extent and say, okay. What you'll notice is that within my site, that is one thing that I think has been added. I think it's hidden down here. But that polygon has been added as part of the elements within our site. Okay. Can you see it here? There it is. So we have demarcated the extent of our primary school. Okay. Again, it will not be 100% accurate. That's why you must always corroborate this information with the information that you get in your survey maps. Survey maps are accurate. As long as they have been properly done, they're accurate, and you'll get that has even better information than this, okay? Now, the other polygon that I will want to define is my road, okay? As you can see, we have a very important road, and we have various internal roads. So for this presentation, allow me just to handle the external road. But ideally, when you're modeling, you also have to pick up all internal roads. For the external road, I will model it maybe to the extent of our site. So allow me to start here. So I can call it main road. Okay. So if I say main road, the color, it's always good to put it at around 100 so that you are able to see. And since I know it's in tarmac, allow me to use black for now. Then I'll change the opacity later. The 100 helps you in quickly picking up the extent of your. So let me do it again. Sorry, that one I mixed up a little bit. So this one, main road. Because you have not used it, you'll see it somewhere down there, but we'll delete it, okay? So before you say okay, you have to define the extent of your road. So for us, we'll define the extent of our road based on that edge that we are seeing. The beauty is that while doing this, you can even zoom in for clarity. Can zoom in and get and make some judgments that are extremely correct. Okay. When you zoom in, you minimize the possibilities of errors. Remember, I'm doing my road to the extent of our contour. So I'll switch somewhere there and take a corner and start coming back. As you can see, that contrast, you can easily pick up the extent of the road. You lose nothing by zooming in. Here we can easily pick up the corners of the extent of our school. Where you have a corner, it's always good to use small to refine that corner. You should use small internodes, but where you see it straight, you can run it all the way, okay? So you have a corner, always try and put a corner, okay? That one I've pushed a little bit so I can adjust it. So if I click there, it clearly shows that I'm done. So if I say okay, we'll have our main road there, okay? So for now, you have seen how we can use a polygon to define the extent of our site and to define the extent of our road, okay? In another tutorial, I'll show you how to use the placeholder, okay? At this level, you lose nothing by even trying to measure, okay? For me, let me, for example, measure between the two blocks. If I measure from here to here, gives me around 30 meters, which is more or less consistent to what we have on site, okay? So as you can see, this is a very important tool that if you learn how to use it, it makes your life very easy, okay? So having done that, I would want us to now I need to deactivate the ruler. We have deactivated it so we can easily zoom in. So we have gotten the two critical things. We have gotten the extent of our site. We have gotten our road. So the next thing now will be to export it. But before I export it, I always like moving my my Google Earth file. I like moving it to my places so that it's no longer a temporary file, okay? But it's one of my many files, okay? Here it is, Makuyu. And this Makuyu, you can easily, any time I access Google Earth, I'll be able to pick it. You see, it will be one of the many that I have, okay? As you can see, the information about the contours has also been picked up, okay? So we can easily pick up the lowest contour, which is this one. This is our lowest contour, 1398. And we can see our highest contour is 1425. That in 1425 is this one, okay? Again, it's corroborating the information that we had on Contour Map Creator, okay? Now, when modeling, it's not advisable to use the absolute heights. What we shall use is a datum height, so we can take our 1398 as a 0. So it means that this one will be 0, 1, 2, 3, 4, 5, 6, all the way to around 27, okay? So take note of that because that will be important when we are modeling. Remember what I mentioned about the road? Because I started one of it and I did not finish it, it has been placed here, but we don't need it. So we need to go and check which is which, okay? So I will hide that one. And as you can see, it hides our road. I want to bring it back. Let me hide this one. This one, as you can see, there's nothing, okay? So all what I need to do is now to delete it. Okay, so with that now I have a complete map, a KML map that has the contours, that has the extent of the site that is of my interest, that has a road or a number of roads. So once we have done that, we will need to export this. So how do we export it? You save as. And when saving as, you now save it as a Flynn. Okay, we save it as no, we now save it as a KMZ. I'm trying to look for where I've saved my tutorials. Have a folder on YouTube tutorials. YouTube tutorials. I seem not to get it right now. I'd reorganize my sheet a little bit, so allow me to place them here for the time being. Okay, so again, when saving, ensure that you have a name that you'll remember about the site, and ensure that you indicate the contour interval. And this is important because we'll handle thousands of sites and always not put it in your head which is where. Okay, so if I say save, it will be saved as a KMZ file. So by now, I believe you have seen the difference of the various files that we are using. We have handled a KML file to export from the contour map creator to Google Earth. Now you want to use a KMZ file to export our site to Archicad. So let us do that, okay? You do that by either in opening it directly in Archicad. So let us just open our Archicad file. So you have various ways of importing that KMZ. One, you can open it directly. Two, you can import. Three, you can merge. So it all depends on what you'll want to use. Okay, so let us quickly open it. As it is opening for now, allow me to use the standard template because of time. As it's opening, again, remember, you download this KML file. Remember, you have to put all the relevant metadata, the contour, the extent of our site, the top leftmost and the bottom rightmost. You must define the contour interval. Okay. So let's open it. So we open. So we'll open where you have just saved it. If I go to my quicks, I should be able to pick it. What I'm looking for is a KML or a KMZ, sorry, a Google Earth file. Okay. So with that Google Earth file, as you can see, it's under my recent, but I will lose nothing by trying to locate where it is to confirm is the one. So there it is. So if I say open, it will specifically open that file. I personally prefer this option so that your site is independent of every other thing that you do. So along the way, we'll have a tutorial of how to import your properly modeled site onto your workspace, okay? So for now, in an ideal situation, I'm supposed to indicate the altitude, but for now, I will not indicate it, so allow me to click continue. And with that, you can see you already have a site. We have the information, okay? The site might look blank, but what's helping us is that the feel of the road is helping us see some white lines, okay? So by default, those contours are normally shown using polylines. And those polylines, as you can see there, they're normally white in color, okay? So the first thing that you do is to select all polylines and change the color. For me, I will use a black color so that you're able to see all of them, okay? You lose nothing by giving your site a proper boundary, okay? And again, we lose nothing at this level, even by showing the extent of our road reserve. Okay. So with this, for me, we have sorted out the most basic things. And what I'm just simply doing is trying to align my road to my site, okay? Now, let's just do a bit of interaction with our site. I want us just to measure some 2 or 3 things. If we measure the extent of our site, we can pick it as around 60 meters. Let's measure the extent of our road reserve. Does it make sense? Yes, it does make sense. It's a road reserve of 12 meters. So that one makes a bit of sense. The only thing that you'll notice that along the way, some parts might not have been defined properly. So it now gives you a chance to start correcting that. How do we correct it? Correct it by overlaying your line on it. Overlay your line on it. My interest will be the low one, so that now I just adjust it by 12 meters. So allow me to move it outwards by around 100 meters. No, this one is big, maybe 1,000,000. Ensure that while you are aligning, you are moving it horizontally. Okay. All what I need is the lower part, so I can and select that part, then delete the remaining area, so that now with this, I can duplicate it. And now since I know that my road reserve is 12 meters, I can easily offset by 12 meters. Okay. Then come and top up there and there. So for now, I know that that will clearly give a better presentation of my road. So I can move it. While moving it, as you can see now, we have a conflict between the older and the new one. I don't believe in deleting, so I will hide. So I will hide that, and I'll remain with that. And as you can see, it's a bit polished compared to the original one. Okay, so we have defined our road. We can align these two at this level. It's just a bit of movement, but we should have done that before offsetting. So let me so they will have a small problem. This also needs to be offset, but that one will sort out. But generally, we have our site, we have our road, okay? So the next step I want us to do is to model. And for us to model, we must show our contour intervals. You show the contour intervals by labeling. I think by now you know the pattern of our site. The pattern of our site is that I'm trying to see if I can change the let me save site and in it let me save map. At this level, let's see if you can define using a better scale. Let's say let's use 1 to 200. Okay, so with that, we can easily label all our contour intervals. It's deliberate so that we don't get confused when you're actually modeling. In my affinity for black. Now, let's use this one as plus 0, 0, 0. We know that we'll go beyond 10 meters, so I can put 5 digits so that everything is consistent. So does that mean it means that this one is plus 1000? And I will continue that way, plus 2000. So for you, because you are starting, you'll have to do it manually for all of them. So that's plus 1000, 2000, 3000, 4000, all the way. As you know, we have a high level here and we have a high level here. Let us look for example, this contour is plus what? This contour, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So this is plus 19. This will be 20, 21, 22. This will be 23. And because we know our patterns properly, this being 19, okay, then you can clearly pick up these things, okay? The beauty about them is that if I, for example, pick up that contour, it shows me the pattern of the whole thing, okay? If I pick up that one, it shows me the pattern. If I pick up that one, so it tells me that all that's at the same level, okay? So once you have picked up that, we now need to quickly draft the extent of our contour. Ideally, just need to look for the topmost point and the edges of the contours will assist you. That's the the easternmost side of our site. The same case with that. The same case with that. Same case with this. Okay. As you can see, based on a contour interval, all our contours are aligned, so it's no problem. But at times, when you're not so sure about the alignment, you normally offset that line a little bit inside, even if it's by 100 millimeters, just to ensure that this interaction between the contour line and that edge, that's very critical. When you have a situation where they don't interact, for example, something like that, you'll have a problem in modeling. So you must always ensure that they interact. And just to be safe, as I've said, you lose nothing by just pushing, offsetting this one inwards a little bit. Let me offset by 50, because all what I want is for my contours to overrun the extent of my site. That way, I'm very sure that when modeling, nothing will go wrong, okay? So with that, we have the critical ingredients to do our model. The first thing that you do is to go and select the mesh and ensure that information about the mesh is in order. Allow me not to handle that for now, okay? So once you have taken the mesh, use the mesh to show the extent of your site, which is basically that polygon, okay? Let's just open the 3D at this level. You'll clearly see a mesh that is flat terrain, okay? The attributes that you've given it will be reflected. The second step now will be to map your contours, okay? We map our contours by one, ensuring that the mesh tool is on, and two, using the magic wand. The magic wand is a space, okay? When you hold on space, you'll see something like a fly whisk, okay? So what you ensure is that you click on the line when the fly whisk is on it. If you click when it's inside, you can see it changes, okay? You need to click when the fly is on it, okay? So you hold on shift and click there. You'll be asked to create user ridges, okay? There are other options, but this mesh points used to fit to user ridge so that it's aligned to your contour line, okay? So if I say okay, you'll notice that some dots which match the nodes of our polygon will be placed. And I will need to do the same for all the remaining. One of the quickest ways by maybe following the lower part, just always ensure that's on top of the line. And once we have covered all of them that touch the edge, you'll be able to see a line that is selected, or you'll be able to see a node that's highlighted. But while doing that, you lose nothing by just checking how you're progressing. You're progressing well. So as you can see, for those contours that are running throughout the site, by the time I touch that on, I'll have covered most of them. So as you can see, most of the contours, apart from the ones on the other peripheries, and apart from the ones that are showing our ridge that are not touching the periphery, are already placed. So I'll come in and place all those contours. Okay. Also come to this side and sort out these ones. So the only ones remaining are these ones. So as you can see, we have placed all our contours. Okay, those nodes show the nodes in our contour line. Okay, now what we need to do is to start elevating. Okay, remember we started at 0, 0. So this one, if I click the node, I will have the push option of elevating. So I will retain it as 0. Okay. So let me now start elevating. This will be 1 meter. So I will write 1000 and I'll apply to all. When I say apply to all those contour points along that line will be elevated. And you can see the repercussion is that when you elevate, we'll have those secondary lines that clearly show you that that part is sloping. Okay, so those are actually very important just to show you that you are moving in the right direction. If I say 2000, 3000, to move faster, allow me to copy that so that I'll just be pasting and editing. Don't know which one among us the two will be faster. But the key thing is that maybe, so at even note I'm doing, allow me to just do it manually, 6,000, 7,000, 8,000, 9,000. Then I want to go to my 10,000, should be this one. Then 11,000, 12,000, 13,000, 14,000, 15,000, 16,000, 17,000. As you can see, I might have mixed up things along the way because this one is 17. But since I've not forgotten any contour, I think I'm fine. Maybe when I was putting my outer was, that's why I messed up. So this one should be 18,000. Then 19,000. Then 20,000. And 21,000. And 22,000. Okay, so as you can see, those areas where you're seeing the secondary green lines, that tells you that those areas are modeled. However, remember that there are some areas that those contours don't touch, so we need to go and sort out those areas. A good area is here. Now, we know very well that it is sloping downwards towards your right. So it means that now, once you have picked up this contour H, that one is 0. Let's confirm. That is 18,000. Yeah, that's 0 because we were not adjusted. So this one must be 9. This is 17. This is 18. So you can see the pattern. Okay. So 17, 18. Let's even try this one. This one is the 17. So that is 16, 17, 18. So it's just logical that this one be 19. So that is 19. Then we go to 20. This must be 21. But just put and see. This is 20. Yeah, so this is 21. This is 22. This is 23. This is 24. This is 25. This is 26. This is 27. Now let's go back here. Let's look at the pattern. This is 10,000. This is 9,000. This is 8,000. So it's just logical that this will be 7,000. We are going downwards. This is 6,000. That is 5,000. Okay. I think you have sorted out that area. As I said, if you see those secondary lines in green, it tells you at least that area is modeled. So I think you have sorted out that area, this area, this area. So the part that is remaining is up here. Okay, again, we observe the pattern. From there, 17, 16. So this one will be 15. So that is 15. This is 14. This is 13. This is 12. This is 11. This is 10. This is 9. Okay. So I want us to look at that mesh in 3D. And now you'll see that the mesh, we can feel the terrain apart from a depression. You can see that area is a depression. What does that tell you? It tells you that we have not put those, and here it is. That's an interesting one. So that is 17. That is 16. Then no, logically this is 15,000. Okay, so let's look at our 3D again. Now we don't have that depression, okay? But you'll notice that the terrain now is sloping, it's undulating based on what our model has. We forgot, we mixed up one of the contours there, so we need to go and pick it up and see where we're having a mix up. I think where we were transiting, yeah. This contour, this one is 10,000. This is 9,000. This one should be 8,000. So we forgot to pick up that. Then this one should be 7,000. Oh, wow, I think we picked up that we had not, we had not consistently finished that area. And as you can see, we have corrected that and that issue has been resolved, okay? We have a part up here that we have not yet modeled. Again, let's look for it. It's up here, that's true. Again, the pattern. Let's start even 4 lines. That is 14,000. That is 13. This is 12. This is 11. So this one should be 11. This one should be 10. This one should be 9. This one should be 8. This one should be 7. And this one should be 6. I hope you have not left any behind. Let's look at it again. Yeah, now you can see our model is quite clean, okay? Now, you remember we moved our outline by 550. It helps us to have a clean edge, okay? If you had not done that, you'll have found all these edges being on this lower point. Will have meant, again, spending more time cleaning the edges. But for me, so far, so good. The only thing that now we need to sort out are the corners, okay? The corners, simply because they're not part of the contours, you have to manually define all the corners, and it's just simple. Suppose we had a contour line running there, what would be the height, okay? So we just need to look at the lowest height, which is 19,000, and the highest height, which is 18,000, and simulate. For me, it's towards the 19,000, so I'll put at 19,700. Again, here, again, you just use logic. Okay, let's go down here. This one is this one is 9,000. This one is 10,000. I'm saying it's more towards 9,000, so I can put it at. So this specific corner, I'll put it at 88. Okay, let's go to the third corner. This one is 8,000. This one is 9,000. For me, it's more or less at the middle, so I can put at 8,500. So you'll see it's just an issue of logic, okay? This one is 0 all the way, so I mean, just logical, that one remains at 0. So let's open our 3D. And as you can see now, the 4 corners have been sorted out. The 4 corners are clean, okay? And as you can see, we have a nice undulating site, which for some of us who have been to Makuyu, it's a representation of that area. We can smoothen it at this level by using all ridges to be smooth, so that when you have our 3D model, it's even smoother. So as you can see, it's very smooth, okay? Now, I want us to define our road. I think that's the main remaining tutorial in this place here. Now, roads are very interesting because they are dynamic. They match the profile of our mesh, okay? So it will be difficult to use a slab. It will be difficult to use something that is not that dynamic, okay? One of the easiest ways of getting it is by simply using your mesh. So how do you use your mesh? You make a copy of the mesh by dragging. So I'll drag the road and also drag the mesh. I'll drag it with a dimension that I know. So I'll drag it by 1 million. Okay, and then I'm going now to use my mesh. Maybe allow me also to drag the outline. Remember, we had to put an outline. That will not help us so much because it's inside the mesh. Anyway, let me place now that I can see the extent of my mesh, I can quickly place another outline from there, here. Okay, now I want to use the road outline to cut off the other portions that I don't need, okay? So I will select the mesh, select and activate, and then I will cut off the whole of this portion. Okay, how do I cut off? There are many ways. Just to be sure, I can use the subtract from polygon option, but when I cut off, it cuts off the whole portion. As you can see, it has cut off everything on that side. Also want to cut off everything on this side. I'll just remain with the road, okay? If you open it in 3D, you'll see that it matches the pattern of our road. It's undulating as our road. The only thing that you need to do now is you need to acknowledge that the material will be different. So I'll just look for a black material for now to represent tarmac. Allow me to use this for now. Okay, it might not be the best, but I'm limited and I don't want to start making materials now. So if I say okay, I can with a lot of confidence return it back. But for some of us who know how our roads look like, first of all, this one, because of the scale, we have not, maybe we need to do that. So allow me to undo what I've just done. This road reserve of 12 meters normally has a road carriage of around 5 meters. or in this case being 12 meters, it may be even allowed 10 meters. 10 meters might be big. So let's work with 5 meters. So what I need to do is to offset this by 12,000 minus by 3,500. That actually gives us the extent of our road. So that is our road, okay? So I needed to have cut off based on that. So allow me to place the outline again. Then I'll select my mesh and I'll do the subtract option, subtract the whole of that. I'll do the subtract option and subtract the whole of that, okay? So that being our road, I change the material. Our roads are usually slightly above the ground so that the tarmac at least can work properly. So allow me to even push it up by around 50 millimeters for now. Okay, but most importantly, I need to change the cover fill. The cover fill cannot be grass, okay? I just need a black thing for now, so I can use a foreground and change the color to black. So that it's absolutely black. There it is. Now, I will move this one back. Remember, I had moved it by 1 million, so I'll move it back by 1 million. And there it is. Let us look at the model. Have we selected it? We lose nothing even by cutting a section around there, so that we see what happens. So let me cut a section. Okay, they're there. So what might be causing maybe, yeah, this material here, the override is what is causing the problem. So with those two, you can see now our road is snaking through. Okay, so our road is snaking through. The only thing is that we cannot have it that big. So allow me to use the connect tool to quickly sort it out. So if we go to our section again, if I use the connect tool, solid element operation, that will be the target. This will be the operator. And then I'll just subtract, okay? If I subtract, what will remain is just what is above our mesh. And if you look at it, clearly even our section, it gives us a good representation. So my friends, now you'll see you'll have these small pockets. Let's try and push it up by another 50. Will it sort out those issues? Yes, they will be sorted out. So you can see we have a very clean road meandering on our site, okay? So I think with that, I will have finished my presentation of how to use the mesh tool and put your contours, elevate them, and most importantly, show the road that meanders through your site. Thank you.